Hey, what's going on, guys? Let's try this problem right here. Here we have these questions asking find the angle between the inbound and exit ray, right? Now here we have a ray that is acting with this angle. Now let's see what is going to be the angle of exit ray. But before we do this one, we have to understand this concept. Now this is, here we have a ray coming inside, right? It is we call inbound ray. And if it act on a mirror or shiny object, the reflection, right? Reflection, what's going to be the angle of reflection? Now, in order to find this one, what we have to do is we have to draw a normal line between these two rays, that inbound ray and exiting ray. Normal line is the imaginary line you draw perpendicular to the surface, whatever the surface we have, mirror or whatever. If you draw draw a line perpendicular to the surface, that's what we call a normal line. And the angle of inbound ray between inbound ray and the normal line is called angle of incident. And the angle of exiting ray and the normal line, that's we call angle of reflection, right? So these are the two angles, and it's always equal for this kind of surfaces, right? So therefore we know that angle of incident is going to be equal to angle of reflection. So we have to use this concept in order to solve this problem, right? Now here what's going to be the normal line? Normal line is the line that is perpendicular, imaginary line that is perpendicular to the surface. So here we have this ray, inbound ray acting on this surface, and the perpendicular to this surface is going to be like this, right? 90 degree. So it's going to be like this. So this is our normal line. And we know this, if this is 60 degree, this is going to be 30 degree. Right? So let's call this one theta 1. So this is our first angle of incident. So first angle of incident is going to be 30 degree. Now if this is 30 degree, and we know that angle of reflection must be 30 degree because it should be equal, as we seen before, right? So here this should be 30 degree. So theta 2 should be 30 degree. And if this is 30 degree, this must be 60 degree, right? Because we know that total angle is 90 degree. So this must be 60 degree. So let's call this one theta 3, right? So theta 3 is 60 degree. That is this one. Now this is going to go like this, and again it's going to be reflected like this, right? Now the question is asking what is the angle between this and this. Now let's try to figure out these angles. So we have this angle and this angle, right? Again, since this is acting on a mirror or shiny surface, we have to draw a normal line again, right? Let's draw with a different color. So here we have a normal line that's going to be perpendicular to the surface. So this is going to be like this. And if you draw like this, it's come like this. And the question is, what's going to be these angles? Let's call this one theta 4, right? Theta 4, theta 5, and let's call this one theta 6, right? Now we know that this is making a triangle. So here if you notice, here we have a 90 degree. This is a 90 degree, right? And we know that this is 30 degree, this is 30 degree. So this is 30 degree, 90. So this must be 60 degree, right? Theta 4 must be 60 degree. So we know that theta 4 is 60 degree. If this is 60 degree, and according to this concept, we know that angle of incident must be equal to angle of reflection. So here we have this line is reflecting on this side. So this is angle of incident, and that is 60 degrees. Therefore, angle of reflection must be 60 degree. Theta 6 must be 60 degree. Now, the angle we need is all this angle in between this one, right? So if you add them together, 30 plus 30 is 60, 60 plus 60, that's going to be 120, 120 plus 60, that's going to give us 180. So the total angle is 180 degree. So you can say, so, and also you can see that is, if it's 180 degree, it means this is parallel to this one, right? So the answer for this one is find the angle between the inbound and exit ray. The answer is parallel. So parallel, and you can say 0 degree or 180 degree. Both of them are correct. And that's how we do this kind of problems. I hope this video was helpful. See you next time.